You see now, for you to better understand, I placed everything clearly. So list of zip of this thing. If you have 3 pairs, so whichever is the minimum, so it will give those many number of values. So the minimum is like so 1 1 1, so 2 2 2. So whichever is having like 0th position, first positions, like that it will do pairs. So that is the beauty of zip. And like so there were like a couple of interview questions, so based upon this zip, so which is into like how you can make use of it. Say you have like 1 2 3 and AB. Obviously whichever is minimum, so 2, so it will give 2 values. So the first one will give like 1 and A, so 2 and B. And similarly in the second case, what will happen? So lambda x stated so and so, means like that you are making the things complicated. So in this case also you can see the same thing. You see now, just for you to understand, I gave like this. So print of, list of, map of. So over a period of time, this will be very complicated, but it's not that difficult. So if you just focus carefully, you will understand these things. So this is all about these things. Now, going further, I gave a small way for you to understand uh, each value at a time. So, hope you are aware of the Caesar cipher implementation. Caesar cipher, I gave an assignment also. So if you want to implement the same Caesar cipher, I try to give with this. So just ignore the print of list of map of. So you can see now what lambda ch stated ch means if you are given a character, get the character. And map, what it is doing, it will map a function, either it is lambda or ordinary function, any function, to a iterable. Even list is string is also an iterable. So it will map each time and get one value at a time and then get it. So don't you see, you are getting exactly what is needed. Now I will do one more step ahead to it. So what I'll do is like for the same thing, I will add. I will take each value and I try to convert it to ORD. So for a given values, I am converting to ORD, means I will get the corresponding numbers instead of actual values. So instead of characters, their positions I got. Now the same thing. So means for each of the character positions, I want to add 3. That is the, so this value, right? So I do +3. You see, it did a +3 to it. So instead of that numbers, you got like +3. So instead of 80, 83, you got like that. And for this end result number, again you need to convert to a character. CHR. CHR is a built-in function for doing that. If I do now, you see, again I will get the consolidated values, right? Now, what is that I want to do? I want to join them together. So if I was given a word called as Python, and finally I get, if you have a list of strings, how do you join? So you can do delimiter dot join. So delimiter dot join means what? It will try to join the list of strings if you have. So if you have a list of strings, you are doing like this. Means if you have a word called as Python, did you see in one line I could create a Caesar cipher? You remember how earlier how many lines you used to do for the same thing to implement. And similarly, so one more example for you to understand. Just you can see afterwards also. If let's say there were 2 functions which are defined. First function is there, second function is there. And if you want to do like first inner function like this, you see in this case what happened? First the inner function happens first. Means list of filter of f2 comma data, and that result will come as a values to the f1 function and impose. So like this we can do complicated things also. So you need to just focus on understanding, that's it. So this is how you can understand these things. And the one last thing about is called as reduce. So earlier in Python 2, reduce is a built-in function. Now reduce is a part of functools. So they don't want people to use reduce. So that's the reason they did like this. Because like reduce is like something which will go into it. I will show you shortly what is that reduce and how it works. So Okay, so if I take the example of a say map, if I take like, let's say I have, for you to understand, let's take I have like this, lambda x stated x into 2. If you are given a values like this, then I need to multiply by 2, right? So fine. So map, you know, till now, what are the value you give, you need to do it. So, okay, I take the same example again and I take it again. So instead of that, if I pass like say, hey, if I was given two values, then add those two values. If I was given x and y, then add x and y. Means till now in map, you didn't go with two arguments, right? In these examples. Now for the first time, I'm going for two arguments. Then it is saying that, hey, I'm getting every time x. But what is the value of y? Means each time, so if there is only one list, it will get only from one. And if you have two lists, it will get from the second one. Say if I have one more list, say like 10, so 20, so 30, and 40. Now you see in this case, what will happen? As you give two arguments, it expects two iterables. That is a map. Even filter also same thing happens. So filter also, you try doing the same thing with a filter. So there is nothing wrong in trying. So if I give a try, so which is having a boolean true, it is giving the results. Basically, filter expects what is saying? Filter expects two arguments, but you got three arguments. So because like so it is expecting two arguments, but I gave like three arguments. It's saying 1, 2, 3, 4, 1, 2, 3, 4. So the way that you passed, basically this is not the yeah, that's the main thing. Filter actually expects a boolean result. Generally filter no one will use in this case. So it expects like a boolean, like true or false. So that's what, right, you do in general. So that's the reason it's saying so. So leaving it apart. So again, coming back to this map, if I take this time like three arguments, say if you are given like three arguments, say add with the first two, and with the result, you subtract in the third one. If I have something like this, then I need to pass the three arguments. Say like I need to pass x, so 1, 1, 2, 2, 3, 3, 4, 4. If I pass three arguments, now it will work. If I have three functions, I need to pass three arguments. If I have 10 variables, how many arguments I have, those many functions I need to, sorry, those many iterables I need to pass. Okay, one more condition. So what if some of them has not exact same length? Then it will throw in error. So you see what is said? It actually tried to execute, but it gave like one of them as 0 because it took like a default which is 0. So in earlier versions, I think in latest version of Python, they have fixed it. Earlier it used to throw an error that like if one of them is limited, it will do. But now it is good. They have addressed this problem also. So means whatever is the end result, it doesn't mean that everything should be zeros. It somehow the end result is so. So in this case also it came like that. So fine. Now we understood about it. Now let me go for the examples of the same map. Instead of a map, I do with a reduce. Hope you understood how reduce came to picture. So reduce means from func tools. So import reduce. It's kind of a selective import. But reduce will not take like 3, 4, 10 arguments. So if you give like it will take arguments, but like it will take only two arguments. What is saying? Expected at most three arguments, but got four. But like so, what is saying? I got like four arguments. What do you mean by these four arguments? So means like it not expect these many arguments. Means reduce will work on a single iterable. Means it won't take these many things. Only one of them it will take. So iterator should be only one. And on top, it will work on these things. Means it expects only two arguments in a lambda, or like any function you define within them. So, and within that, it will work. Now see what will happen. So the way reduce works is slightly different from others. It will take two arguments. So what is saying? Int object is not iterable. X comma y stated. What is that? Yeah. Sorry. So again, we need not convert to list. That's what one more point. Because reduce, unlike the map and filter, it will give a single value. Reduce will give a single value, unlike others. You see now how different it is there. I changed a lot of things. It will take a lambda or an ordinary function, but that function should have only two arguments passed. And within the two arguments only, you do whatever operations you want to do. And you need to give only a single iterable. It will work on that single iterable for doing whatever you want. So now you see what will happen. If I do like, if I want to do multiply them, you can multiply it. So don't you think like it's a factorial? So it is same like a factorial, right? So 4 into 3 into 2 into 1. So what are the end result is there? So or like if you make one of them as 0, then you will observe the difference, how it works. If say one of them is 0, you see what will happen? Means how it actually does all these things. It's very simple. First, it will take the two arguments and do the operations on those two, and then that result will go further. Say like initially 1, so x will be 1, so y will be 2. So then like what will happen? So the result after doing multiplication, x will become 2, so y will become, so what is the next value? 3. So after that 2 3s are 6, so x will become 6 and y will become, what is that? 4. So after that like 6 4s are 24, like y will become 0. So and after that if you multiply both, so you get like 0. Is it clear how it's working? So lambda work on a single argument, so like this. So if I do like an operation, you see, this time example, see here, I'm doing an exponent operation, x to the power of 2 y, means it is like 1 to the power of 2, that result to the power of 2, so 3, that result to the power of 4, like that. Now what will happen in this case? It is doing like this. So 1 to the power of 2, so that result is there, right? That result to the power of 3, so that result to the power of 4. This is what happening. So anything to the power of 1 is 1. That's what happens, right? So if I do the same thing, so in much better way, means first value, if I remove the 2, 1. So subsequently from 2 onwards it will execute. So it will not have this one. So this result will be again 2. So from there onwards it's gonna execute. So 2 to the power of anything means you get the value. 2 to the power of 3 is, 3 is 2 to the 4, 4 to the 8. So 8 to the power of 4, like that. It will execute. So hope now you understood what is a lambda, how it's gonna work, how it is helping you. Any doubt till now? Okay, so I'll take as a no. Now, so after this lambdas, so we have next thing about recursions. This is another very interesting point. What is a recursion? So how it can help us? So recursion means calling the same function again and again. So calling the same function again and again means like, I would say in the other way is like, to understand is, yeah, okay. Say I have a function, so which has a return value, which is again the same function. Say I have some example like this. I have a function which you are making a call. Within that you are printing, and finally it has a return, which is again the function call to the same function. Just imagine like how it would be. It's a terrible idea, right? It will execute and execute and execute, and it will finally fail. So that is one problem. So for you to better understand these recursions, rather than going in a Jupyter notebook or something, so I will go with something else where you can better understand. So there is something called as a recursions visualizer. If you see the recursions visualizer, so it is one of the programs someone has created to help us. So let me take one thing here. Yeah. So define hello. Okay. If I have like print out, say, so I need to make a call to it. Hello of, it's an empty function. Just I'm making a call. It is just a function which will execute. So there is nothing here to say. It is one stack. So whereas function will execute and so and so. And if I have a function with a return of hello, if I execute again, it will show the result. So earlier you just made a call. This time you are giving a result, which is a hello. That is also fine. Now this time instead of a hello as a result, I will do hello call. So there is no limit. Infinitely it will execute. Each one will call itself like that. So those kind of things are very hard to even debug also because it can go to infinity, right? So to avoid that, what we can do? So what we can do is like, so anytime when you're writing a recursion function, you need to remember what is that so you are doing, and you should do with a reason actually. So whenever you are taking, say, one good example, if you have a list of values and you want to add, say, define sum of the values. If you are given like numbers and you want to sum them, say I am taking the same thing, sum of values. Within that, I was giving like 1, 2, 3, 4, 5. I have. So now you need to sum them. If I do in this case also, say a simple return, so sum of values of again numbers, if I say, then what will happen? Every time it will recursively go on like that, it will throw. So that is again like a while loop, which is infinitely going. So every time when you're writing a recursion condition, two things you need to remember. So you need to know when to terminate it. And so how we are working. So in this condition, not every time the return should be same. So you are taking the zeroth value every time. And like you are doing a sum operation. Means from 1 onwards you are doing. If I do like this, now you see in this case, what will happen? If I print numbers, right? Numbers. Now we see what will happen. Instead of a typical return, it is executing and it throwing. So, so it cannot visualize that better than. So we can do that in our phone. So you see here, rather than that, as a commenting it, you can see this function. And if I say like sum of values, 1, 2, 3, 4, you can observe that it is giving all the values as we designed. So now from this, if you see, it is executing, and finally it will throw in. Oh, it don't have a condition. Okay. So you see what will happen? Initially all the values, next 3 values, next 2 values, next 1, next empty. So what is the error? It is nothing to do with the recursions. It is saying that index error. Hey, after doing all these things, I cannot do further. So now we see what we'll do. So we need to At one point, the things are becoming empty. Then you want to stop. So the when if length of numbers is equal to 0, then you want to return. So you want to return what? So as you are doing a sum, so for everything you are adding, right? So you do a return of 0. Now you see what will happen. So every time you are returning everything and you are getting a final result. You see find print of f of, if I do the same thing, did you see what happened now? You get the sum also printed. So not only this, I can do the logic slightly differently. Why every time you want to go to the last value, I can go to the last but one value, right? So in that case, I can go nums of 0, because on that time it will have only one value. Means you are avoiding one of the loops, that's it. But logic you write on your own however you want. But you wrote two things. You have a return also same thing, but every time we need to do diminishing, reducing the total size, and somehow you are doing it. So, and like this, you can take one more example. Say like the sum of values, you can do straight away in a direct way also. Means any problem we can solve in this kind of recursive way approach, or in a for loop also you can do, right? You can take the same numbers and do. So whichever is best means. So generally, iteration based approach is suitable when you go for anything, but recursions are suitable whenever you are going for the same logic being done for different values. If that kind of things are there, it's fine. But one problem with recursions is that they occupy a lot of space. Now we understood a good amount of a recursion, right? So let me try doing the same thing over there. If I take the same example there and I want to execute the sum of values, I took the sum of values and executing. Now you see what will happen. The sum of values, each time it will create, right? So initially you asked these values, sum of values of 5. Then it is giving like, it is making a call to sum of values of from 3 onwards. Then sum of values of 4 to so and so. Sum of values of 5 to so and so. Next 5. Then finally this last loop is giving a 5 because the last value. So that 5 is passing to this. That last value, what are the results are coming, it is going. Did you understand? All right. Let me do one more example. So reverse a string. Reverse string. If you are given like a name and you want to reverse it. So the simple logic, so you get each time one value at a time. Say return. So name of 0 each time. So plus reverse string of name of 1 onwards. This is how you have. At one point, what will happen? It will name because it will become empty. So in that case, you want to do if name is equal to empty, you can say like return empty you want to do, because empty if you add also it will be the same thing. If I take the same thing here, I make a call reverse function of, say I gave the word Python, and if I execute, you get the same thing. First call, like it will have Python. That will take one value, first value, and give the next Python to it. That will give the one more value and give to the next value. That will give one more thing, like that it happens, right? So if you see, so I wrote a logic which is mistake. Due to that, the result is also Python, but I want it in the reverse way. Means the 0th value should go in the last, right? So 0th value should go in the last. Now this time I execute again. You can notice that you are getting same like this, the reverse of Python, right? So don't you think you wrote this logic correctly? So 0th value you place in the last and do it. Or so you can do the same thing in other side also. So means like instead of that, I can take the last value and place it in the start. How to get the last value? Name of -1 plus, I want all the values till the last value. Means colon -1 So all the values still like this. The same problem I can approach in different ways. So finally I got the result, right? So like that, you can do recursive problems. So any problem can be solved. So like that or like this. So one last problem to solve and we can jump on to the next thing. So there is something called as Fibonacci series. If you see about the Fibonacci, so Fibonacci series is like, if you give any number, the first two numbers will be 0 and 1, and subsequently it would be like, so 0, 1, and the subsequently it's a summation of previous two. 0 and 1 if you add, you will get 2. So 1 and 1 if you add, you will get 2. So means 2, 3 you add 3. So 3, 2, 3 you add 5. 3, 5 you add, so you get 8. Like that, if you combine the previous two numbers, you get the next value. That is how you have. That kind of things if you want to do, so I will do the same thing. Define. So fib of, if you are given a number, so for that we need to do. So every time what you understood, you need to return the previous two values, right? So Fibonacci of n minus 1 plus Fibonacci of n minus 2. So this is the return logic. In the return logic also we have the same function call. So it is a recursive function. Now we need to have a condition where to stop. So I told you for the last two values, right? If n equal to 0, then you say return 0. So if n equal to 1, you want to return 1, right? So return 0, and you have like, so elif, so n equal to 1, you want to return 1, something you have. Now based upon this I want to execute, say Fibonacci of say 5. Now if I try to visualize it, did you notice 5 will create two things? So 4 and 3, right? So 4 and 3 came. Again this 3 will create 2 and 1. So and like this 2, it will create 1 and 0. And similarly, so you told to stop at 0 and 1, right? So that's why it stopped there. And similarly 4, it is generating these two. So again, this is generating, and each one is giving back the values. Hope you understood how things are working. So this is how you take like more than one. So recursive calls with more than one, right? So that is how it works. So any doubt? Okay. So like this. So but like if you don't give the conditions, it will go to the infinite conditions and will throw in error. So let me go back to the condition infinite loops. So the same examples whatever I wrote, I placed it here. And if I go to like infinite loop, so if I have the if you give a name, it will print the same thing multiple times, right? If I say like display of say Python, you see now what will happen? So it will go on printing. So after one point, what will happen? So it will throw in error. Did you see what is the error it is saying? Recursion error, maximum depth, recursion depth exceeded by calling an object. So for the first time, you are seeing a new kind of error. Means if you don't handle the conditions properly, it will give something like this. So what is this and how to understand it? So there is, what is this recursion depth? Means there is a module called as a sys module. Hope you remember. Using sys module, there is something called as get recursion limit. So if you go in the script mode, so script mode, it is like 1000 and like 3000 for interactive mode. Because Python when created, you don't know what is Jupyter Notebook, but Python has interactive mode and script mode, right? Script mode in a script you write. In interactive mode, because you have a lot of program running, so multiple numbers, that's why they give you a stack which is better, more. So that's why the limit is 300, means 300 frames. Earlier you saw, right? One function is asking another functions like that. Each of them is called as a frame. Just imagine like you have a table. On table you are opening your first book. So you have a doubt and you open another book, another book, another book. how many books you can open and place based upon the size of the table, right? You can't go more than the size of the table. In the same fashion, within the computer also, we have something called as heap memory, which is a private heap we have for Python. Within that private heap, whatever the size is there, those many frames only you can create. Beyond that, you cannot create. To accidentally avoid like the Python program to crash, so they have made some limit called as get recursion limit. This recursion limit is by default set like this. But if you want to set this recursion limit, there is a way to set the limit. And if I say like I want to set the limit to something, say if I made the set the limit to 1500, and if I ask, did you see the recursion limit was decreased to 1500? So you need to know like how much time your function is executing, and is it executing for all these 1500 times. For that, let me write a small function. So loop of number of recursions. Every time inside I will try to increment the value and I print it. So now I need to call. So loop of number of recursions I need to give. So say like the value is 0 initially. So it will execute. Did you see this is a recursion 1, recursion 2, like that? How many times it is executing? Till 1471. So means, sir, we told 1500, right? Even the Python program, so how many programs are running here? So functions which are created here, all this needs some kind of storage, right? That's the reason the remaining 30 were chosen for that. Maybe I take the example again. This time I set the recursion to something small or big. So generally don't touch it. But in sometimes if you want to use for that particular program in that situation, you can change it. But what are the changes you did will be there only to that program only. So if I change to 250 now, so the values will be 250. And if I make the call again, you can notice that if I take the same example again, if I execute, you can notice that, you see, it is going till 250 I gave. So 221 I have only give. Remaining 30 took. So that is how recursion depth is there. But this you can understand. This is very easy for you to digest also. But the problem is recursion. So infinite loop can not only happen directly with the same function. If let's say you have another example, this time I have two functions, function 1 and function 2. So what I'm doing from function 1, I'm calling a function 2. From function 2, I'm calling function 1. Theoretically, it is not a recursion, right? But don't you think internally it is doing recursion only? From first function, it will go to second function. From second function, it will go to first function. So if you call any one of them, you will notice that sync. So you see here what happened. So I gave the limit as 250, right? So there are two functions. Means each one can go like 125, that much only. You see, function 1, function 2, function 1, function 2. Till how much time it did? So 110 and 111. So because like 225, 220 I told, right? Something. So which was divided. So the stack limit, recursion limit will be there. So if you want to, some cases like if you want to use bigger recursions for your purposes, you can use it. But it is not a good practice over a period of time. So the last thing that you want to see is about inner functions. Inner function means what? So till now, like you have a outer, say like I have inner, something I wrote. So define inner function. Say define in outer function. So there are like two functions you have. Just assume that for a moment that I have two separate functions. Okay, inner and outer. Now you see in this case, if I make a call to outer function and inner function, in both the cases it works, right? Both functions you can make a call. Now let me take one more example. This time I'm passing this function to inside it. So this is what? So a function within a function, right? Function within function. So in this case, if you make a call, so you can make a call to, so it is taking to the outer function. Say I'm taking examples like 2, because whatever is defined outside it is using. earlier what was defined, it is trying to use the same. So if I do like this, in this case, see here what happens. You can make a call to the outer to function, but inner to function, when you're making a call, it is saying you cannot make a call. So there will be some use cases where, let's say a simple example, you want to validate whether user is a valid person or not. After validating that user is proper person, and you want some logic to be executed, or you want to give access to something, in that case, you by default don't want to give the actual logic. So you want to hide here, and you want to do validation, and only if user is valid, then you want to print it something if you have. So in those cases, we need to go for this kind of inner functions. So simply, so validation. So if validation is true, so then you can do, say like, if you are given a define, so validation of number. If you are given a number, so if number, so percentile 2 equal to 0, means if it is a even, so only in that case you want to execute the inner function. Say define, so print number. Only if it is a number, in that case you want to do. If you have something, so you can say like print of, so even number is a number. Okay, something you have, a function within a function. So if I do like validation of 22, if I execute, you see now in this case, if I execute, so if 22 percentile 2 is equal to 0, I gave a number and it should print, right? But you see it's not printing. So you can't call from outside, but somewhere you should call, right? That is from inside. Means inside when you call, so can you call like, so here, so print function of number. Can I do like print function of number? So maybe like here an underscore for just to understand, like this I do. If I execute, what will happen? You cannot call any function before definition. Any function call should happen only after definition. Means first you define, so either outside or whatever may be, and you can call it. So did you see now what will happen? You have a function which was defined, and then you're making a call. So did you see now what happened? Even number function was executed. So from outside you have a function. From that function you call the inner function. So how you made this inner function call? So within the outer function, right? So within the outer function. So these kind of things you have. This is called as the inner function. So what is the purpose of these inner functions? Your function has some kind of context, and if you want to use that, then you can do. So maybe like, let me give one more example. So multiply of say number 1 you have. So if number 1, so percentile 2, so just percentile 2 means what? So if it is like odd, then like define multiply 2, I have, so assume that multiply 2 of say number 2 I'm taking, and I want to return, so number 1 into number 2. You see now, so the outer function, the context, inner function context, both it is taking and doing. Now you do like, multiply 2 of n1 comma n2. What are yours given to you? You want to just execute it. So